Okay, this next chapter here, chapter 34, Simplifying Logic Circuits. Again, this is going to be a chapter that I do not utilize the slides, and I am going to show you a technique on simplifying logic circuits. I should have been recording that.
Yeah, you can do it again. We'll let that out. Go ahead and hit the red button.
So, where's the red button now?
Should be
Control, toggle record pause with Alt-P. Alt-P.
there you go.
Okay. One of the things that I want to show you is chapter 34, Simplifying Logic Circuits. I am not going to use these slides for this chapter, although I am going to show you how to simplify logic circuits and show you an approved method that I want you to utilize. In following the text is going to show you Karnaugh mapping and Veitch diagrams. And again, as an exercise at home for homework, I would like to see you try to simplify a logic circuit by utilizing that technique, just so you're aware of it. Again, for the job interview, when you go out and they say, do you know what a Veitch diagram is? Yes. Do you know what Karnaugh, do you have Karnaugh knowledge? Yes, I do. This would all be a good thing. But what I do want to show you is what I would expect one to use in industry, and that is a simplification program. What I'm going to introduce to you is Multisim. On all of our computers here, we have a site license for Multisim 9. That's like what's on my machine right here. So go ahead and launch that from the computer. How many of you in here are familiar with Multisim, have done some playing around with Multisim? Okay. If not, you're going to have to spend some quality time with Multisim. It's a very powerful program. This is a very, very good program because you could simulate the operation of basically analog or digital or hybrid circuits, combination of analog and digital circuits together. But the main thing that I want to show you here today are the different logic circuits that are available and how we could simplify those circuits. Now, up here in the upper left-hand corner, you see we have place TTL and we have place CMOS. TTL stands for transistor-transistor logic. A lot of these logic gates in the past were made out of nothing more than old-school transistors shrunk into a package that's called integrated circuits. Remember that chapter? And then we create logic gates. We also have CMOS. Do you remember what CMOS stands for? Very good, MOS, metal oxide semiconductor. CMOS is complementary metal oxide semiconductors. So basically everything that were the metal oxide semiconductors, these are the chips that you could fry through electrostatic discharge. TTL were not very prone to electrostatic discharge. CMOS is much higher efficiency, so TTL has all but been replaced in industry right now. As a matter of fact, for like our parts kits, we're having a hard time even sourcing parts in TTL because they're becoming quite rare. But anyway, we have the choice of both right in here. So let me just select your TTL. And then we've got a variety of different families of TTL that are available. We got the 74 STD, 74S, 74LS, 74F, 74 ALS, 74 AS. Let's just go here with the 74 LS. And then look at all of the components that are available. Let me start on this here. Let me start up at the top. Can you all recognize that symbol, what that symbol is? It's a NAND gate. Very good. NAND gate. That's a NAND gate. What's that? NOR gate. NAND gate. Inverter. It's an AND gate. There's a variety of flip-flops in here and other components that you could take. Schmidt trigger, that's an exclusive OR gate. So it's got all these components, and you know what? This is cheaper than going to the parts store because they're all available right here. Okay. So if I want to place this in my circuit now, I just select this component and then I go OK. I'll select A there and then I'll place the component. And there's my component on my workspace. Now, the big device that I want to show you, what this is all about, is located over here on the right. Is this logic converter. So I select it and then I drag it over here and I place it. When I double click on it, left double click, it opens up the logic converter and I can actually see my inputs. I've got inputs A through H and then I have an output. So the way that this device is going to work is I could go ahead and connect my A input to my A input, my B input to my B input, and then my output into my logic converter output. Then all I have to do is select this top tab on my logic converter, which goes gate to truth table. Why doesn't it, this is not giving me the right answer. Why does it do that? Why does it do that? Oh. Come on, connect, connect, connect. Why isn't it connecting? Sometimes the thing has a mind of its own. Oops. Maybe if I move it, it'll help. It helped. It helped. There it is. So you see how it gave me the correct answer? A 0 and a 0 gives me a 0, a 0 and a 1 gives me a 0, 0, a 1 and a 0 give me a 0, and only a 1 and a 1 gives me a 1. So it just gave me that equivalent. Now the nice thing is, once I have it in here, I could go truth table to Boolean expression by clicking this tab. So I'll click on this tab and look at what it gives me down below in this queue. I know it's really small on the screen, but you see the A and B? I could also go truth table to simplified Boolean expression. Or I could go Boolean expression to truth table. I'll show you how to do that in a second. Or Boolean expression to logic gates. This is actually if I wanted to build something from a Boolean expression. And I could go Boolean expression to something made out of nothing more than NAND gates. So let me show you the real magic of this. Has anybody tried dabbling in this chapter yet? Homework? Be honest with me. No? You haven't gotten as far yet? Good. Good. This is the perfect time. This is the only time that I like to lecture before you try to do the homework. Okay? So what I'm going to do here is I'm going to clear this out. Okay, Lena, in your text, let's look at one of these difficult problems here. Let's look at page 333. And let's look at, let's go with C. at 34.1, questions 34.1c. Okay? Now, I'm going to have you read that to me, and I'm going to enter that in the logic converter. But in order for us to get it right, you got to say it right. Because if you don't say it right, I ain't going to do it right, and then we're going to end up with goofy results. So let me clear this out of here. Okay? So I've put my cursor now in that Boolean Q in the logic converter. Now I'm ready to go. Okay, so the way we would say that, A and B not. So the B has a not after it. Okay, so the A and the B are not knotted together. It's the A and B not A and B not. Okay, so watch how I enter this. A and B, and then I use a hyphen here. That's the not symbol. Hyphen, apostrophe. That's an apostrophe. Not a hyphen. It's an apostrophe. Apostrophe, excuse me. I don't even know my keys here. Apostrophe. Okay. Or A apostrophe and B and D. So I've got, let's just review this. A and B not, or A not and B and D. Okay? Or
B not and C not and D.
B not and C not and D.
Or
Or
B not and C not. Or
B not and C not. I'm sorry.
B not, C not, or A not and B and C and D equal 1.
Okay. So let's read through this again just to make sure. This is, again, what is this, 34? 34.1c, okay? Let's go with a read back here. A and B not, or A not and B and D, or B not and C not and D, or B not and C not, or A not, B, C and D. You concur? Okay, now comes the fun part. Once we have it in Boolean, like what I'm going to give you on the quiz, like your homework problem, now I could go Boolean expression to truth table. So first of all, before I click this, because I always want you to anticipate your results. I don't expect you to anticipate the answer, but I expect you to anticipate the results. How many inputs are we dealing with here? 4. So how many different combinations am I going to end up with? 16. Okay, so it's going to be 0 through 15. Does that make sense? So when I click that, I should see this whole queue here get lined up at least all the way through 0, 1, 5, all the way up to 15, because I'm dealing with a 4-input problem, Boolean problem. Make sense? Okay, so I'm going to go ahead and click that button and watch what happens. Pow, there's my truth table. It just built it for me. Once I have the truth table, I could go from the truth table now to the simplified Boolean expression. This is really what you're doing in Karnaugh mapping, right? You're trying to go from a complex Boolean expression and simplify it to a simplified Boolean expression. Once I have that truth table, now I can click on this tab and it's going to simplify the Boolean expression for me. Okay, you ready? 3, 2, 1, click. There's the simplified Boolean expression. A naught and B and D, or B and C naught, or A and B naught. That's your answer. But for those of you at home, guess what? It gets even better. It gets even better. If you physically, ultimately, why you would do this is to build this circuit, to give you this logic condition. So if you wanted to build this circuit now, all that you would do is go from Boolean expression, simplified Boolean expression here, so it has the fewest number of parts, to logic gate. So when I click that tab, failed to find a component in database. Uh-oh. That's not good. I don't know why it's coming up with that good grief. Something might be wrong with this database, might be corrupted, because there shouldn't be anything wacky out of this. Let me, just for giggles, let me close this all. Save this file? No. Okay. So let me try to reinitialize Multisim. Are you ready to read that to me again? We'll do it real quick this time. Okay, we'll go to max time reached.
Okay, well, just,
Click done.
Yeah, we're gonna wanna actually have that go over to Firefox real fast.
No problem.
It's gonna
Meanwhile, back at the farm,
take. Yes. So, do you mind if we wait for this to finish exporting and then do a second part? Okay. Cool. So,
no, I could quit now, but they'd never see it work.
yes.
I think I'm full of it.
You could give it a dry run while this is exporting. Multisim.
Knew that. See if it's going to work.
Yeah.
Logic converter, place, pow pow, Boolean expression.
A and B not,
I'm sorry, A and B not.
or A not and B and D, or B not, C not, and D, or B not and C not, or A not and B and C and D, or one.
Okay, so I'll go Boolean to truth, truth to simplified, simplified to crap. How could this be, man? How can this be? Let's try, okay, well, no, I don't want to try that. What's corrupted in here? What is corrupt?
So you were doing the
What's corrupt?
simplified to the thing. Try doing the A-B thing straight.
There's
from
the, see,
when you enter it in.
made it out of NAND gates. Try entering what?
Try clearing that out. Your truth tables up there, and try doing the A-B to gates directly from when you input it.
Yeah, we could try that, but, well, let's see. So I got to go. I'll just have to re-enter the whole thing. Caitlin's getting good at this. I'm going to have it memorized. I'm going to have nightmares of this.
A and B not,
A and B not,
or,
or.
hold on. You have A.
Oh! Ha ha! You caught me, B not. Or.
A not and B and D, or B not and C not and D, or B not and C not, or A not and B and C and D.
Okay, let's try to go directly to this.
No.
Test point 1 failed to find a component in database. Good grief.
Good golly, Miss Molly, huh?
You know, it's probably these cats downloaded some nonsense to this.
I think he created over here, so it must be your computer.
Really?
What's going on over there?
I think he was able to do that on computer, so it must be.
Oh, yeah.
But all of these, this is server based, so.
That's kind of funky.
Yeah, because this should be just, as you saw, I restarted this here. And it created yours A-OK. Really, give me another one, Kaylin. Maybe something's goofy with that. Give me the one before it, the more complex one.
A and B and C and D.
I could do that, A and B and C and D.
Or A and B naught and C naught
Hold it, A and B naught and C naught
and D.
and D.
Or A naught and B and C and D naught. Or A naught and B naught and C naught and D. Or A and B naught and C naught and D naught. Or A naught and B naught and C and D. Or
Are you making this up?
A and B and C naught and D naught.
Okay.
Weird stuff.
Don't know. You got it to work on yours, so this must be a fault with something running on this computer.
We could set up the same thing on his computer, the screen recorder thing, and still do the audio. It's working.
Could do that. Want to do it?
Yeah, let's do it. Do you mind?
Huh.